Hi, I'm Cooper Miller,
And I'm Hunter Miller.
and for our final project, we decided to do a traffic light and crosswalk project. Our objectives were creating and implementing a timing system for an old stoplight and crosswalk using an operand arduino, an 8-channel relay to control which lights are on at any given time. We started by creating a small-scale model to make sure all components worked, and we moved on to create a program to cycle through the lights on a specific time and schedule. We also plan to replace old wiring, cleaning up the inside of the old stoplight, and implementing a switch to turn off the Arduino to save battery. We created a crosswalk sign for pedestrians, a red signal indicating do not walk, and a white to tell them that they can walk. The components and cost, we ordered the off-brand Arduino and relay on Amazon for $25. We also bought an on-off switch for around $7 and plastic conduit for $6. The rest of the materials we either had or were recycled. Project overview, Hunter's father had the old stoplight housing in his game room. It still worked, but it didn't cycle through the lights. All the lights just stayed on. So we plan to use what we had learned in this class to wire and implement a system to control the lights. It was also conveniently close to Christmas, so this made a great present for his dad. This was a very educational and applicable experience to our future careers by making a plan and model, testing the components, reorganizing and replacing old equipment, programming the system, and putting it all together is what we're going to need to know as engineers. The application of engineering design to produce solutions for public health, stoplights create a safe environment where multiple roads meet. Public safety, stoplights need to be well made so that they stay working with minimal maintenance, thus promoting public safety and safety of the workers tasked with doing the maintenance. Public welfare, our design is good for the public by being aesthetically pleasing and fun for personal use, and in the real world, it promotes general safety. For global, cultural, social, environmental, and economic factors, traffic lights are designed to allow smooth transportation, thus keeping the economy running. And using this simple design for personal use could be great social piece, allowing for easy conversation. For our project, we started with a small-scale version on our electronics fun kit breadboards that we had for class. We also used this time to get the programming for the Arduino right. Once we found a correctly functioning design and program, we moved on to the large scale and final version of the project. Real world applications. In these three pictures, you can see our design on the very far left and right being used for the personal use. And then in the middle, you can see an actual stoplight. Here's our parts and components that we used throughout the project. Description of the subsystems. The off-brand Arduino is a microcontroller board which has different programmable outputs. These programs are loaded onto it using a software called Arduino IDE. The 8-channel relay is used to control high voltages and low voltage by connecting it to an MCU. Design constraints. The biggest one was space within the housing. To combat this, we implemented a plastic conduit, and we also separated the Arduino and relay into separate compartments, spreading our work out over multiple compartments. We also rewired the inside completely in order to clean up the previous design. Cost is also another large constraint. This is because components need to be minimalized to reduce cost. Also with taxpayer money at stake, this is especially important. Or in the case of personal use design that we created, keeping the cost down for consumers would be great for selling to individuals. A simple design is also important because it reduces chance of failure in complex parts and the need of constant maintenance.
So these are some pictures of the inside of our light. The first one is kind of in the middle steps of our hardware stuff. So this is our relay, all the power flowing into it, and the output of the relays to the lights. This is after we introduced the plastic conduit in the middle compartment to clean things up. This is where the Arduino was placed originally, in the top compartment. We can put them separate to save space for the most part and keep things separate for maintenance purposes. Then up here, you can see where we implemented the switch to turn off the computing part that turn off the Arduino so that you could save battery. And this is the scorch mark from one of our incidents when we were performing maintenance, that electricity arced onto like a metal bar behind the light and created that scorch mark on the side and tripped a breaker. It was a great learning experience. So this is the hardware implemented in our design. So for the programming, we use an Arduino IDE as the software. Our operand Arduino was compatible with the software, so this was the best one to use. So this is the program that we wrote. We found a similar program on Arduino's website. So we were able to use that one and change it to complete the task that we wanted to implement the other inputs for the crosswalk and so forth, but created our own from what they originally gave us. So right here you can see I introduced the variables, the green, yellow, and red lights, along with the walk and stop signal for the crosswalk. And this is the rest of the code, pretty self-explanatory. These are the high and low inputs going into the relay for each scenario, the green, yellow, and red light. And right here you can see when we implemented our design and our program onto the breadboard to make sure it worked properly. It worked exactly as we wanted it to. Then when we were testing and everything, we implemented the relay along with the Arduino for the breadboard, and we realized that something was wrong because it was giving us the opposite output of what we wanted. Like when the green light was supposed to be on, the yellow and red were on. We didn't know why at first, so my first solution was to change the program and change all the previously high outputs to low and vice versa. But then once we realized that the relay had a normally closed inputs and normally open inputs. So originally we had them in the normally open so that the circuits weren't closed, allowing signal speed to the lights unless there was a high input. So we changed it to the normally closed so that so once we realized that we needed to change it to the normally closed inputs, we switched it back, and then we changed our program back to what it originally was so that everything worked the way that we wanted it to. And then we also had to add to the program when we implemented the crosswalk sign because we had to introduce new variables and stuff to make the program work the way we wanted it to. So this next slide, it'll change. There we go. So these 3 videos show us testing out our different steps throughout the process. This first one is showing when we tested out our program on the breadboard. The second one shows when we implemented the switch into the light. And the third one shows when we implemented the crosswalk into the light to go along with the light. So we're not going to go through them right now to save time, but I encourage you to watch them later. So for the future design, we could change up our design a little bit to make it more compact. That was the biggest challenge, is fitting everything in the housing. We could also allow it to be more user-friendly by allowing the user to control how fast the lights change and certain things by using a certain switch. And then we could also find a way to advertise and market it to different bars and stuff, or for people to use in their man caves or their shops or game rooms like we did here. We also thought about adding audio sensors to make the lights flash their music, which would be great for sports bars, dancing clubs, or like just for personal use as well. We also thought about using LED bulbs to minimize electrical costs, which would be good for long-term use. And then these are just our references from the components we bought and the websites we used to find like the programming and such. Thank you. All right, so this is our stoplight. We implemented the switch because this is how this is normally displayed. All the lights are on, so we put in the switch to turn on the computing part. So once you hit it, it starts the sequence of going through the green, yellow, and red. And this is the crosswalk, going from don't walk, which is the red, to walk, which is white when it goes to red. All right, so this is the inside. So this is where we put the relay. We routed the power through it and then the outputs to each of the lights. And then this is the top where we put the Arduino and the battery supply for that, along with the switch that you can reach this top hole. So, yep, that's basically it. Thanks for watching.